So, as it is clear that light and the related phenomena are the part of our syllabus, and this is okay. And the related phenomena that we have to discuss here is polarization in detail and other part. So this light is, you see, this is the light. Whenever we talk about the light, then there is a two waves, electric wave and magnetic waves. These two waves comes into the picture, and these waves are propagated in the perpendicular to each other and perpendicular to the direction of motion. And there are several scientists who gives their different concept regarding the light, right from the Sir Isaac Newton, Christian Huygens, and Robert Hooke. These three scientists give the lectures on the light and propose that the light is a particle beam stream of the particles, and it was first proposed by Sir Isaac Newton in 17th century and named as corpuscular theory. And then thereafter there is a modification by Robert Hooke and Christian, believe that the waves that propagate behave like wave. The light behave as both wave and as a particle. Later on, our modern time, light undergoes interference, diffraction, as all waves do. But whenever light is emitted, it is always done so in the packet called photons. So whenever there is a transition of the energy states E1 to E2 in the energy atomic state, then from higher energy to lower energy, the jump of electron produce the light photon. So these photons carry momentum, but not mass in the sense of the light. So this one is the modern concept of light. The light is having a photon which has no mass, but there is a momentum. So at present, light is both particle as well as wave. So these scientists gives their idea in different way, in different circumstances. So finally, what we have, light is an electromagnetic wave. As light travels through space, and electric and magnetic oscillators perpendicular to the wave direction and perpendicular to each other. A light wave is a transverse rather than longitudinal, but you see the other kind of wave, that is mechanical wave, that are longitudinal, since each field oscillates in a plane perpendicular to the direction of wave. So nothing is physically moving in a light wave. Light wave में कोई ऐसा matter नहीं है जो move करता है. Nothing is that, and that's why there is no mass. But light requires no medium. It can travel through the space that contains matter such as air, glass, water, or through a vacuum. Light कहीं से गुजर सकता है, even though vacuum से इसको गुजरने के लिए कोई medium की जरूरत नहीं है. यदि ऐसा होता, if light did need medium in order to propagate, then the earth would spend its day submerged in dark and the sun would not be visible. यदि ऐसा होता कि लाइट के लिए मीडियम की जरूरत है, तो दिस डायग्राम से दैट हमें लाइट को देखने के लिए और उसको सबमर्ज मैंने डे सनराइज और सन सेट करने के लिए it will take a longer time. Sometimes it is in the form of the day. So the electromagnetic wave means there are several frequency and wavelength. So the electric field and magnetic field, these two are shown in this diagram. Along the y-axis, the horizontal wave is electric wave indicated in the diagram with the dark blue, and by the black wave, this is the magnetic wave. So these waves, that is along the x-axis and along the y-axis, these two type of waves are perpendicular to each other, and the direction of propagation is along z-axis. So here it is the z-axis. So wave travels in this direction. Now this one produced due to the oscillating electron. You see this point origin, the origin is indicated as the oscillating electron, and when electron oscillate, when electron move, then these kind of the waves are produced, and these are the form of the light. So the wavelength and the amplitude, that is as the previous concept of the wavelength, that is for a complete wave, that is crust to crust, yeah, trough to trough, it is a wavelength, and the maximum height is amplitude. So it is represented by lambda, that is wavelength, and a amplitude of the waves. Now higher the frequency of light, higher the energy of wave, and lower the frequency of light, lower the energy of the wave. And wave has different colors due to its wavelength. So the longest wavelength of light is of red. This is 650 nanometer. And then orange, 600 nanometer. Then yellow, that is 580 nanometer. Green, 530 nanometer. Blue, 470 nanometer. And violet is 400 nanometer. So if this wavelength is there, nanometer, then this corresponding frequency is of the TH, terahertz. Tera means 10 to the power 12. So the red has longest wavelength 650, and its frequency is 462 terahertz. Similarly, violet has the smallest wavelength, that is 400 nanometer. Then its frequency is 750 into 10 to the power 12 hertz, that is terahertz. So these waves ranges from 650 nanometer to 400 nanometer. And this wavelength can be calculated, simulated with this formula, where c is speed of light and its value is 3 into 10 to the power 8. F is the frequency in hertz, lambda is the wavelength in meter. So on the basis of this, we can calculate the other parameters. Now, suppose this one is the symbol of sun, and here it is earth. Then from sun to earth, the light travels like this. So this is the visible light, then the ultraviolet, and then the infrared light. This way is the transmission of light from sun to earth. So wavelength of the electromagnetic spectrum gives the visible light is a smaller part of the energy range of electromagnetic wave. The whole range is called the electromagnetic spectrum, and the visible is one of the in between, middle part of the spectrum. So we can see the electromagnetic spectrum. This is the electromagnetic spectrum, in which this one is the visible light. This visible light has the wavelength as we have 650 nanometer to 400 nanometer from red end to violet end. And the other waves are known as radio and television waves, microwaves, infrared waves, ultraviolet light, X-ray and gamma. So highest wavelength is radio wave and lowest is gamma ray. And the frequency in terms of frequency, so gamma has highest frequency and radio will lowest frequency. And these are the symbols, that is the higher energy has the higher frequency and shorter wavelength. Here the lower energy is the lower wavelength and the longer wavelength. Means radio and television have lesser energy in comparison to the other waves are gamma ray. Now the application area where these waves are used. So the radio and television waves used in case of radar, that is detection of the object in sky, then radio communication, then television communication, and the wireless network, that is we are connected with the mobile. So mobile is connected with the wireless network. So in that way, the radio and television waves used. Then microwave, it is used in the cooking of the food, microwave oven in the form, and then the cell phone, that is we are connected. Infrared light, it is the heat and lamp and TV remote control that gives the infrared light that is used. Ultraviolet light is used to sterilize black lights. And X-ray is in medicine, industry, and the research. In medicine, someone has the fracture, the dislocation part in the body due to some application of force or torque, then there is a need of the structure, there's medicine. Industry, it is used to find out in several areas of application, to find out flaws, to find out the structure, and to find out the geometry of the crystal, that is research, XRD. Now, gamma ray, again, there is a use in medicine, research, and the most important part of gamma ray is nuclear energy, that is power plant. So in the various power plant in our country, that is Bhabha Atomic Research Center, that is the center to study the nuclear energy plant. So the gamma ray is used over there. So now there are several applications, phenomena of light, and it's related. These are the list of the applications, but we have to study a very limited part of this one is phenomena. There are several topics like polarizer, interference, diffraction, dispersion, and scattering. But here we will concentrate on polarization only. The other part will be discussed in next semesters, in physics as well. So the first thing, that is if you have a film, that is on the rainy day, we see that on the roadside there is a color on the water surface. So that color due to the thin film of oil on the water surface. So how can this thin film will produce the different reflected waves, and these waves interfere and construct the pattern that are visualized in this way. And the basis of reflection is as simple as it was in case of mechanical waves, that is the waves coming with the refractive index lower, and there is a higher refractive index material, then it will behave like reflector. So Na and Nb, these are two refractive indices of two medium, and Na is this is greater, and Nb is this is less. So it will reflect and pass both. Here it is, if Na is equal to Nb, then the wave is propagated as it is. And if this this kind of wave is there, so major part is reflected and lesser part is transmitted. So the reflection and the refraction are based on this phenomena of the reflector. When the refractive index is less than other, so one is known as rarer, other is known as denser media. And in this way, here it is glass plate, and then there is a film, And this film is a non-reflecting, means it is transmitting and reflecting both. So non-reflective coating, if there is a coating on the surface of the glass, then that can gives the path difference as well as the physical thickness of the material. And this can be calculated here as if the thickness is lambda by 4. If the thickness is lambda by 4, then going from lambda and coming to this, so this will make the lambda by 4 thickness makes the path difference 2t transverse in both the direction. So 2 into lambda 2 by 2, that is lambda by 2. So there is a path difference of lambda by 2. So lambda 2 by 2 is the destructive interference considered. And this gives the relation, that is lambda by 2 is the path difference. So it is equal to the optical path difference when multiplied with the reflective index N2. So 2t into N2 be the optical path length, and that is lambda 1 by 2, and this 2t is the physical path, that is actual thickness of the material in which light is propagating. Now, the second important concept is the Newton's ring. This based on the, basically Newton's ring is based on the interference, and in interference there are two types of interference. One is division of amplitude, other is division of wavefront. So division of wavefront is used in case of Young's double slit experiment, when we will find the spacing fringes in alternatively dark and bright fringes. But in the case of division of amplitude, there is a circular fringes, and this was studied by the Sir Newton's, and it is known as Newton's ring. So in this diagram, you see this one is a plate, and here it is a plano-convex lens. Plano-convex lens is placed on the plate. So these are the vase-shaped film, and this vase-shaped film gives the constructive and destructive interference pattern of the reflective, and this kind of the rings are formed in the rings are more clear in this way, and therefore on the basis of this ring and the interference pattern, we can calculate the radius of the ring, and along with the radius we can also calculate the various refractive index of the liquid in the rings. Now diffraction and interference both have the interference, only few waves are superimposed, while diffraction large number of waves are superimposed. So in this case here this is the disc, and this compact CD we have like a diffracting grating. This we have like a diffracting grating, and the color and the intensity of the reflective grating is varying from place to place, and that can be obtained with the help of the resolution and the distance. So if this one is aperture through which light is passing, and here is the two object placing separating at S0 and making angle theta, so S0 by P, the position from aperture, is the resolution. These are the angle limit, and the limit in angle of resolution is equal to theta 0, that is 1.22 into lambda upon d. This, the lambda is the wavelength, d is the aperture diameter, and here it is S0 by P. This S0 is R. The angle is equal to, basic definition of angle is equal to arc by length, arc by radius something. So this is the d diameter of the aperture. So lambda upon d multiply 1.22 is the angle of resolution. And this angle of resolution for the circular aperture is identified in this diagram, where this is maximum at a 0 intensity and the minimum intensity is at minus 1.22 lambda upon d, and here it is 1.22 lambda upon d in positive sign of the theta. And this resolution gives the condition that how two objects are clearly visualized, and that is known as Rayleigh criteria for resolving two objects. You see, there are two patterns. As here it is one pattern, there is a two patterns. If two patterns are formed and the maxima of one pattern lie minima of another pattern. So here it is the maxima of this first pattern is just above the minima of the second, and the minima of maxima of the second is just lie on minima of first. So in this condition is fulfilled, then the object is clearly resolved. So this resolution can be visualized again in the same pattern as the theta slit lambda by A, that is resolution is 1.22 lambda upon D. And if this one condition is fulfilled, then the two objects are separated. If there is a overlapping, so these two objects are not separating in the clear distinct. So the vision is defined in this condition, that is when we see an object and these two objects are visualized, then the diffraction patterns must be in this way, and that is the limit of resolution, and which has to be fulfilled in this way, and it is criteria of the Rayleigh's criteria for resolution. Now in case of our human eye, the angular resolution of human eye can be having the diameter is 4 millimeter typical, and green light with the wavelength is 500 nanometer. So this can be, so this green light lambda is 500 nanometer, and the dq is 1.22, and this I by d, that is lambda wavelength 500 nanometers, so it is 0.5 into 10 to the power minus 6, and this diameter is 4 nanometer, that is 4 into 10 to the power minus 3. This can be written in this form, and therefore this dq is equal to 0.14 milliradian. So minimum useful spacing of rod and cones. Rod and cones we will discuss in the detail of the structure of eye where this can be happen. So this have idea of the 3 mm. So and then at that case we can visualize the object. The object minimum resolution is that is 3 mm for the resolution. So in our interest, we have to start this phenomena on the basis of the simple condition of the light is the polarization, because the bio have more human physiology is related to polarization. So what is the polarization? When there are two waves, one is electric component, other is magnetic component. When both these waves are perpendicular to each other and moving perpendicular to the direction of purpose constitute the light. So one of the component, that is electric component, because it is linear, circular is the magnetic in nature. So electric components remains the output, then it is called as the polarized light. Then when light consists the electric vectors, and this can be obtained by the several process, that is polarization of a light. First is selective absorption, second is reflection, third is double refraction, fourth is scattering, and there are many more process through which we can have the light. So this can simply demonstrate that is vertically polarized light. If this is the vertical plane and waves are propagating like this, so it is called as a vertically polarized light, and it is symbolized as the straight line. Here the string is moving in a horizontal way, so it is called horizontally polarized light, and symbolically this has drawn by a line, horizontal line. So the whole apparatus, the whole phenomena can be visualized in this way. Here the ordinary light, that is unpolarized light, is there, and this unpolarized light gives the many arrows in the this part, and this light is incident on a polarizer. This is the polarizer, and this polarizer, that is a transmission axis of this polarizer. When light incident parallel to this transmission axis, then it is passed, and this is the polarized light, which is E0, that is electric component. And then if this light is passing through another polarizer, that is known as analyzer. If it is passes through the analyzer and it is rotating, then there is a change of intensity of the light, then we call it light is a polarized light. And this can be observed with a certain law, and this law is known as law of Malus. What law is Malus? As there is a polarizer here, see it, and light is incident. This is the unpolarized light, which give the arrow like this, horizontal as well as vertical, these two diagrams, which the intensity is I0. So this light is passing through the sheet, then we'll get only polarized light and vertical arrow. This vertical arrow, both headed arrow, represent the polarized light, and its intensity is 1/2, 1/2 of I0. So I0 is the intensity, and the polarized light intensity I is equal to I0/2. But if the light is not incident vertically, if it is incident with a certain angle, then the component, vertical component of that electric vector, that is E cos theta. So E cos theta is responsible for the light intensity in transmitted wave. And in this, the vertical polarized. And then the intensity is expressed I is equal to I0 cos square theta, cos square theta. So so this one is the Malus law, through where we can give the intensity. Now, if the light is a reflection, this is the unpolarized light. Here, the incident of unpolarized light at the angle of theta p, polarizing angle. And then there is a reflection of ray with the theta p, that is polarizing angle. And some part of the ray will refracted, so it is theta r. So it is the theta r. So what we find, these ray means reflected ray and the refracting ray, both are at 90 degree perpendicular to the each other, 90 degree. Then there is a light is reflected light as well as transmitted light. Both lights are polarizer, but larger is reflected and lesser is transmitted. But if there is a successive medium is there, then finally the transmitted light will also be a polarizer light. And this can be deduced through the Brewster's law, and the